Hello. So I've been asked a couple of times if I can make a video, a little bit more of an in-depth video. It's not a tutorial at all, but a little bit more of an in-depth video on surface mount desoldering and soldering. Now, I'm no expert. I'm far from being an expert on the subject, but I've got a lot of experience in it. I mean, I've worked in electronics for 30 odd years and surface mount technology in probably 20 odd years or so. And as I said, I'm not an expert. And there's various different ways to remove surface mount components. There's various different ways. The easiest way is with a hot air blower or a hot air rework tool. You can get them coupled with a soldering iron. So you have a soldering iron on one side and the hot air rework tool on the other, and it's all one complete package. I still use separate. So I've got my trusty old Weller, which I've had for so long I can't remember how long I've had it. It's been that long. It's an old 24 volt, 45 watts temperature controlled pencil is what it's called. It's quite, I suppose it's quite big by today's standards. Some of the irons we've got in work are not much bigger than this brush here to work with. They're very tiny. But, you know, I'm used to this. I've used this for a long time, maybe 20 odd years or so I've had this. And it's been a real good iron. I've replaced the element a couple of times. And of course, replace the tips. But the element quite a few times. And they're cheap enough really. And it just keeps on going. It just keeps on going. So, for hot air blowers, I've got 3 of them here. So these are the 2 I normally use, and they've got different nozzles. This nozzle is slightly smaller than this one, as you can see it there. So and of course you can change the tips. There's one with a smaller tip as well, and of course I'd use this tip if I'm removing, say, a single transistor. I just use that smaller tip. If I want to remove a large IC, then you know I change nozzles depending on the size of the component which I want to desolder from the PCB. Obviously, the bigger the component you want to unsolder or desolder, then generally the bigger the nozzle. Otherwise, you're just wasting heat, and you'll never get the solder to go molten, so you can remove the component in one go. So you want enough air coverage, enough coverage to completely cover the part really. Otherwise, I mean, with a big IC like this, you're running around the outside. You've warmed up this side here, and by the time you get to this side, warming up this side, that side's gone cold again. So you're just constantly doing that, and you'll never get the component or the board hot enough without damaging it to safely remove the component. So you use different size nozzles. So, you're also going to want something like a spyglass for inspection. Some Captain tape as well. I showed what this is for in a previous video. And there's not much else to it really. Obviously, something which you can't buy is experience or skill, and that just comes down to how much soldering you do. You just get better and better at it the more you do it. So we'll remove this IC here. You can see it. We'll remove this IC here and then put it back on. Reusing a component, especially an IC like this, is not as easy as removing a component and putting a brand new one on. A brand new one won't have any solder on the legs or anything. It'll lie flat because there's no solder on the legs to keep it or to make it at different varying heights. So you'll just lie flat and you can resolder it and it'll be fine. But reusing a component is a little bit more harder to do. But we'll give it a go. So let me just zoom in. Let me just zoom in a bit. Okay, so I'm going to use the. Let's have a look here. Let's see which one I'm going to use. This one, this nozzle should be okay. So this is the slightly smaller one out of the two. So I'll use this hot air tool. Saves having two, just saves having to let this one cool down before you can remove the nozzle and replace it. You know what I mean? So it's just easier having two. This is just the cheap ones. This is just a cheap one, about 20 quid on eBay, and you know, for general hobbyist use, it's perfectly good enough. So we'll turn it on. So I've got the air pressure and the heat virtually at maximum. It's not the most powerfulest tool in the world. So the heat and the air pressure is at maximum. So I'm going to put something underneath the board to stop it from rocking. And we'll remove that now. So obviously the board is cold. There's a possibility if you overheat it too quickly that you delaminate it, where the different layers of the circuit board come apart and it'll blow. It'll start to puff up. The board will start to puff up. It won't be flat anymore. It'll start to puff up. So you've got to be careful on how you heat it. So preheating is always good if you can. But as this is a scrap PCB, it's of no use, then we'll just go ahead and remove it. Obviously the board is cold and it's sucking a fair bit of heat out, the board is, but there's the component now off the board. It's obviously very hot, so I'll put it to one side to cool. Put the hot air blower on the stand. So there we go. So there's the part we just removed, U3 on the board. And we'll now put it back on. So this is the one we just removed. We'll put it back on now. Let's see if I can get the board a bit more stable. I've just got my roller tape underneath to stop it from rocking. So we're going to need some flux. Yeah. Okay. Use a flux pen or a flux dispenser or liquid flux, whatever the case may be. We'll take the IC. And you could, if you wanted to, use the soldering iron to solder it back in place. But it's easier to use the rework tool, the hot air blower. Okay, and now we'll inspect that and see if it's lined up okay. It's this one. So there we go. It's looking good. Yeah, it's looking good. So there's a slightly, what are we to here? There's a slightly larger IC there. So for that one, I'm going to use the other hot air blower because it's got a wider nozzle. So we'll remove this one and give that one a go. So this one here, if you'll focus, remove this one. I need to prop it up a little bit. So it's that one there. I'm going to have to adjust the settings on the blower. It's taking some time to remove it. Let me just adjust the settings. Okay, I've increased the heat a little bit. Not go too much. This is an 8-layer board and it does suck a lot of heat out. But it should have come away by now. Let me try the other blower. There's more airflow on this one. There we go. So it's obviously extremely hot. Okay, so that's the IC there. That's the IC. It'll focus. Okay, that's the IC. So we'll put it back onto the board now. So some flux. You can see the Gw0wvl by there. Okay. So if you can see the solder, Gw0wvl. You can see the solder is virtually shorting out on the other pads. That will be okay because once the solder goes molten again, once it's been reworked, the solder will flow and it'll pull itself back onto the pad. So you really don't have to do anything with that apart from just rework it as you would normally. So let's put the IC in place. Saying let's put the IC in place. My tweezers are not quite wide enough to hold that, so I've just had to. So we'll put this IC back there. It's U14 on the board, and the solder, once it's molten, it should pull the IC back into place. I'll try and line it up a little bit first. Hard to do left-handed because I'm right-handed. Okay, let's have a look at U14. Board is extremely hot, as you can imagine. Ooh, really hot. Gw0wvl, there we are. So there is U14. I think we've got a couple of little shorts by there. Which I'll have to have a look at now. So I'll have a quick look. Yeah, there is one or two. There's one or two minor little strands of solder. On the IC, which, if we warm it up again with a bit of extra flux, it should be fine. And we'll do the other side as well. So we'll do the other side as well. Hard to do because the camera's in the way and I keep bumping it. So we'll have another look and see what that looks like now. Let me just... Okay, yeah, that's looking better. That's looking better. So, where are we to? U14. Okay. So U14 is being put back in place. There's still a little. Where are we to? I think there's still a little wisp of solder there, but it's not much. The other legs have cleaned up nicely. There's still a little bit there which we'll just redo again. Maybe it didn't get quite hot enough. And apply the old flux. Camera's out of focus all the time. You could use a soldering iron for this and drag the solder. Which is always a possibility. It should go molten. Okay. Let's have another look. Just cleaning up just a little bit as well. Flux has made it look messy. Flux has made it look messy. So let's have a look to see what Gw0wvl looks like. It looks pretty good. So where are we to? There we are. So there's Gw0wvl removed off the board and put back on. So things like where are we to? This transistor is very, very simple to do. So we'll remove that one. If it'll focus again. Okay, there we go. So we'll remove that. Now the board is actually got nice and hot anyway from our previous reworking. It doesn't take as much heat now to remove the components because the board is already hot. Although this 8-layer board still sucks a lot of heat away. There we go. So it's off the board. Where did they come from? They come from there. So if we just apply a bit of flux, we can put it back. I called it a transistor, but it's yeah, it is transistor. It's Gw0wvl. I thought it said D12 then. That's the trouble. The component can get blown off the board. And that is a problem with a hot air blower. Okay, the D12 is back in place. We'll have a look. Gw0wvl, sorry, is back in place. We'll have a look. Okay, it's a little bit messy. It's a little bit messy. Where we two, but it's back in place. So we can clean it up with a little bit of IPA. There we go. So this is where we two. That's the IC we removed earlier. Okay, we could go for a larger IC, I suppose. What we got here? We could try and remove this pick chip. We could try and remove this this pick chip here. Obviously, that's a quad flat pack. We'll give that a go. We turn the soldering iron off. It's just clicking away. And let's see what we've got. Okay, circuit boards all over the place now. So we'll try and remove this IC here, which is a microchip picture. U3 on the board. Obviously the PCB is cold, so it's going to take a little bit longer. Got to warm up first. So there we go. There's our IC off the board. To put it back, it's a reverse. Obviously you don't want the board to get cold now, otherwise you're going to have to heat it back up again. So the pinouts are, pin 1 is here. That denotes pin 1. So even though the board is no good, we'll put the IC back where it should be. Lined up. Looks okay. We'll have a look a little bit closer. I think we might have a short on one leg, but we'll have a look. No, looks okay. Okay, so this was the where we two. This was the IC we took off. Looks a little bit messy. You can see the flux around it. So we'll clean this up. We have IPA on the toothbrush. Obviously the board is extremely hot, and the IPA is just evaporating the minute you touch it. But there we go. So that looks pretty good. Okay, so as you can see, there is nothing really special or difficult really about surface mount technology. In fact, on times it can be easier. Well, I would say it probably is a lot easier than through hole, especially through hole with plated holes. Some through holes, such as these here, where these pins would be, these pins, they're plated through holes. So you've got a copper track on the top, a copper track on the bottom, and there's a piece of copper like a tube that joins both of them together, and they can be really difficult to get out. They can be really difficult, but yeah, I mean, as we see here, board is now cooled off a fair bit. As you can see, there is not a lot involved with replacing surface mount components, just as long as you have the correct tools, and just as long as you've got the correct tools and you know what you're doing. If you go into it not knowing what you're doing, then obviously you're going to mess it up. You can, or there's a possibility that you could cause the board to delaminate. The layers of the board where they just come away. If you can see it on, this board at all. Let's have a look. I'm not sure if it'll focus in on the edge. But this is a multi-layered board. This is an 8-layered PCB. This is a multi-layer PCB. It says layer down in the corner there, but I know that this is an 8-layer PCB. And they can be very difficult to work on. But as you saw, surface mount is no more difficult really than normal through-hole soldering. Just as long as you've got the right or the correct tools, you know what you're doing. You've used the tools before. You know what you're doing. You know roughly for the sort of board you're using, where you put the heat and the amount of flow for the air from the blower, and those things are just things that you can't be taught. It's just something you have to learn by using the tools you have. And yeah, have a go at SMD, surface mount, because it's not as difficult as it first appears.